Welcome back, students. In this video, we're going to work on Module 3, Topic 8 and 10. This is slope and equations of lines. The standard for this topic is GR 3.3. Use coordinate geometry to solve mathematical and real-world geometric problems, including lines, circles, triangles, and quadrilaterals. The objective for this topic, you guys are going to classify lines as parallel, perpendicular, or neither by using the slope criteria. And the essential question for this topic is, how can you tell if a pair of lines are parallel or perpendicular or neither? This topic goes right into the guided notes. Just a moment. Just write both of these. Okay. Slope is the ratio of change in the y-coordinate, rise, to the corresponding change in the x-coordinate, run, as you move from one point to another along a line. Of course, rise is our up and down, and run is our left to right, up and down being vertical, left to right being horizontal. So slope equals m. That's the rise over the run, as it mentioned up here. That's the change in the y divided by the change in the x. This little triangle means change, so change in y divided by change in x. And that's also the y sub 2 minus y sub 1 divided by x sub 2 minus x sub 1, where x sub 1 is not equal to x sub 2. And, we've talked about this formula a couple of times, and you'll probably obviously remember it from previous maths. The slope criteria outlines a method for proving the relationship between lines based on a comparison of the slopes of the lines. You can use the slopes of two lines to determine whether the lines are parallel, perpendicular, or neither. Let's see. So let's scoot this up just a hair. So slopes of parallel lines. Two distinct non-vertical lines have the same slope if and only if they are parallel. All vertical lines are parallel. So slopes for two lines that are parallel, their slopes are equal. Because all vertical lines are parallel. All right, slopes of perpendicular lines. Two non-vertical lines are perpendicular if and only if the product of their slopes is -1. Vertical and horizontal lines are perpendicular. Of course, that's like the axis. That would be the 0, 0 point. Those two lines, that's the x axis and the y axis, and those two come together. They're perpendicular. Yeah, fine. Highlighting. I don't know how this one goes here. Okay, not bad. The product of their slopes is -1. Vertical lines are parallel, and then vertical and horizontal lines are always perpendicular. Sorry, that's not exactly what I wanted to do, but that'll work. All right, neither parallel nor perpendicular. So slopes are non-congruent, and the lines intersect at exactly one point. And so neither, when we look at the slope, they won't be equal, and their products won't equal -1. So let me just draw this real quick. Perpendicular lines come together to make a 90-degree angle. So the product of the slopes equal -1 here. And then slopes aren't equal. Okay. Let's move down the page a little here. Let's see, can we see the whole thing? Just a second. Get a better, there we go. Okay. All right, so our key concept, non-vertical line equations. The slope-intercept form of a linear equation is y equals mx plus b, where m is the slope of the line. Let's see, hold on. So, where m is the slope, there's m, it's a slope. And then where b, that's the y-intercept. So, b is the y-intercept. Okay. The point-slope form of a linear equation is y minus y sub 1 equals m, again, that being the slope, times x minus x sub 1, where x1, y1 is any point on the line and m is the slope of the line. So right here, this would be y minus 5. 5 is your y point here, equals negative 2, that's the slope, times x minus 3, 3 being the x point. All right, let's see. The equation of a horizontal line is y equals b, where b is the y-intercept. So b is still the y-intercept. It's just so like right here, this line. That's your horizontal line, and the b here would be 1, negative 2, negative 3. So this line is y equals negative 3, because negative 3 is where it crosses the y-axis. Excuse me. The equation of a vertical line is x equals a, where a is the x-intercept of the line. So this line here, Lord, I did that backwards. No, I didn't. No, I didn't. Never mind. This is where it crosses the x. Excuse me. So let's see, negative 1, negative 2. So this is x equals negative 2. Negative 2 is where it crosses the x-axis, where that one was y equals negative 3, negative 3 being where it crossed the y-axis. Flip over to page 11. All right, top of the page, left side, the I do. Number 1, state whether the following pairs of lines are parallel, perpendicular, or neither. So, parallel is where they equal. Perpendicular is where their products equal negative 1. That's pretty rough there. Negative 1. And neither is obviously neither. So these are in slope-intercept form, so it's y equals mx plus b. Your m here is 3. So y equals mx, m being negative 1/3 for the second one. Okay, well, these are obviously not equal. Let's try to multiply them. 3 goes into 3 one time. 3 goes into 3 one time. 1 times negative 1 is negative 1. So, ta-da, this one's perpendicular. All right, part B here. These are in the point slope. No, I'm sorry. This first one is in slope intercept. So it's y equals mx, m being 9/7. Should have used a different color, sorry. And the second line is in the point slope form, y minus y sub 1 equals m. So your m here is 9/7. So 9/7 and 9/7. Hey, these guys are equal. So this one is parallel. Put the pencil down so I don't use it the third time. All right, and then lastly, part C is y equals negative 3 and y equals 4. Well, they're not equal. We can't multiply those together. Actually, you know what? Those are not the slope. Hopefully you caught me before I got to that. These are y equals a. These are vertical lines. And vertical lines are always parallel. Okay. All right. Number 2, page 11, this is a you-do. I'm going to wait a moment. Please pause here. Try to work these A, B, and C yourself. Once you're done, unpause and let's go through it together and let's see how you do. All right, number 2, part A. State whether the following pairs of lines are parallel, perpendicular, or neither. So we've got a point slope form here. This is y minus y sub 1 equals, this is your m, so negative 3/4. And then down here we've got y equals mx plus b, or m being negative 3/4. Okay, well, negative 3/4 and negative 3/4 are equal, so these guys are parallel. Let's see. Use a crayon. Okay. B. First line here is y equals mx plus b. Our m is 2. Second line is in point slope form. Y minus y sub 1 equals m, then x minus x sub 1. Our m for the second line here is 1/2. Well, these are not equal. If you multiply these together, you get positive 1, not negative 1. So if we just do this, it would be into 1 that equals 1. So these are neither, because the product doesn't equal negative 1, and they are not equal. All right, and then lastly, part C here. We've got another y equals negative 2, y equals 4. This is y equals a. These are vertical lines. And vertical lines are always parallel. Okay. Well, you can see that it's a little. All right, scooting down. All right, number 3. Determine whether the lines are parallel, perpendicular, or neither. So for this one, we're going to have to plot our points. So we'll start over here with J. J is negative 2, I'm sorry, negative 1, negative 2, 1, 2, 3. So negative 2, 3. K is negative 1, 1, 2, negative 1, negative 1, negative 2. So negative 1, negative 2. L is positive 1, positive 1, positive 2. So this one's 1, 2. And then M is 1, 2, 3. Oops, nope, 1, 2. Negative 1, negative 2. So this one is 2, negative 2. All right, so we're going to do, we're going to use the slope formula, which is, slope is going to be y sub 2 minus y sub 1 over x sub 2 minus x sub 1. We got to do for these, for JK, they're on the same line. J's up here, so x1, y1. K's down here, x2, y2. Same thing over here for L and M. x1, y1, x2, y2. So, for JK. So our y sub 2 is negative 2 for K, minus 3. And then our x's are negative 1 minus negative 2. So that's negative 2 and negative 3 make negative 5. Negative 1 minus negative 2. So these two change that to a positive. So it's negative 1 plus 2. That's negative 1. So negative 5 here for JK. Swap colors for LM. Let's say the y sub 2 is negative 2 minus y sub 1 is 2. X sub 2 is 2 minus 1. Negative 2 and negative 2 make negative 4. 2 minus 1 makes 1. So it's negative 4. So negative 5 does not equal negative 4. And then if you multiply negative 5 times negative 4, you get positive 20. So these lines are neither. Oop, almost went off the screen there. Just you for just a moment. There, sorry about that. All right, number 4 is a you do. Please pause the video here. I'm going to wait about 3 seconds. Please work the problem and see how you did. All right, number 4. Determine whether the lines are parallel, perpendicular, or neither. So we've got our points here, TU, or we'll say UT, and we'll say RS. So just make U R X1, Y1, RT X2, Y2, R is X1, Y1, S is X2, Y2. We will start with UT. So Y2 is 6 minus 0. Our X2 is negative 4 minus 0. So 6 minus 0 is 6. Negative 4 minus 0 is negative 4. For our S, we've got 7 minus negative 3, and then 6 minus negative 8. Okay, so as I've said, the two negatives, that makes it positive. So 7 plus 3 is 10. 6 minus negative 8, that makes it plus. So 6 plus 8 is 14. So these guys are not equal. If you multiply them together, let's see, 2 goes into 4 2 times, 2 goes into 5 times. Yeah, so it's not going to equal, their products are not going to equal negative 1. So these are neither. All right, give me just a moment. Flip over to page 12. All right, top of page 12. Number 5, a we do, so this is an I do. Determine whether lines A, B, and CD are parallel, perpendicular, or neither. They'll give us the coordinates here for both lines. Graph the lines, verify your answer. So AB, I'm going to make it green. And CD, I'm going to make it pink. Okay, so A, we go 3 and 6. So this is A. All right, B has negative 9. And if you guys are having trouble graphing, or plotting your points, so your X is negative 9, so X is this way. So we're going to go negative 9, and then Y is 2, so we go up 2. This is B. Just a moment. I misplaced my... Ow. Okay. So here's your AB. Okay, let's get that out of the way. All right, C is 5, 4, so we go 5 up 4. See? And then D is 2, 3, 1, 2, 3. 2, 1, 2. Did I do that right? 2. Yes, okay. Sorry, it's just kind of late. All right. Okay, so here's our lines. They asked us to graph them, and we can look at that and they look pretty perpendicular, but we can't go by looks. We have to go by the math. So AB, again, and we'll do X1, Y1, X2, Y2. So you'll be X1, Y1, D will be x2, y2. So, for AB, we've got 2 minus 6 on top, negative 9 minus 3 on the bottom. That's 2 minus 6 is negative 4. Negative 9, negative 3 is negative 12. And this will reduce down to negative 1/3. CD. We have 3 minus 4. 2 minus 5. So we got negative 1 on top, negative 3 on bottom. So negative 1/3 is equal to negative 1/3. So these guys are parallel. Okay, scooting down to number 6. Also a we do, which means it's an I do. Write the equation in slope-intercept form for a line perpendicular to y equals 4x minus 9 containing point 8 minus 6. Okay, so first, and you see I got started early here. So first, we find the line that's perpendicular. So this is y equals mx plus b. So our m here is 4. So for this line, if it's 4, we need something that multiplied to that gives us negative 1. And you just take the reciprocal, which if you guys remember back to fractions, 4 is like 4 over 1. The reciprocal is 1/4, but we have to take the negative reciprocal to get negative 1. So 4 times negative 1/4 is negative 1. So we know that the slope for this line is negative 1/4. We'll start building our line here. It's y equals mx plus b. So we need the b. To get the b, we're going to plug in, this is x, this is y. We have to plug that into, give me just a second, I forgot again. Oh yeah, we plug it in to here. I'm going to put it over here. So it's y equals m, this would be x, actually, mx plus b. So we plug the x in for x and the y in for y. So x goes here, y goes here. We're solving for the b, okay? So negative 1/4 times 8. Well, 4 goes into 4 one time. It goes into 8 2 times. 2 times negative 1 is negative 2. The plus b comes down. The negative 6, that's what we plugged in for y. We add 2 to both sides. I just take this up here. So we have b equals negative 6 plus 2 is negative 4. So now our b goes in here. Mess that up. It should be plus b, which if b is a negative, you have to do that. But this is your equation. Y equals mx plus b, or y equals negative 1/4. That's where we found the slope over here. Plus b, or minus 4, because b is negative 4. Just do this real quick. Yeah, there we go. The m was negative 1/4. There we go. All right, scooch down the bottom of the page here. So there's an infinite number of lines that intersect a line and pass through a given point not on the line. However, when determining the distance between the line and the point, you must find the shortest distance between the two. The distance is the length of the segment that is perpendicular to the line through the point. Stay with me. That's a lot of words. Key concept: distance between a point and a line. The distance between a point and a line, The distance between a line and a point not on the line is the length of the segment perpendicular to the line from the point. I'll show you in a diagram here. It'll make better sense. Given AB and point C not on the line, so point C is over here, we're talking about line AB. There's an infinite number of lines that pass through the point and intersect the line. So from C, you could go here, you could go here, you could go here. The shortest distance is this perpendicular line. That is perpendicular because we have the little box. But the distance between C and line segment AB is going to be that perpendicular distance. So from here to where it hits that line. Let's see. Let's read this again. So given AB and point C not on the line, there's an infinite number of lines that pass through the point and intersect the line. The shortest distance between the point and the line is the length of the segment perpendicular to the line through the point. So the distance between C and AB is CD, as I was saying. It's very wordy, but that's what it's trying to tell you. So let's flip over to page 13. This is the last page of this lesson. Top of the page, left side, number 7 say I do. Find the distance between point A to line BD. All right, so from A to BD here, it's going to be this. Basically, we're going to get the measurement from here to here. So we're going to use the distance formula. The distance is, excuse me one second. Sorry, so y sub 2 minus y sub 1 squared plus, x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. So we got over into the other side here, where A is going to be our x1, y1, and C is going to be our x2, y2. So let's just plug them in. So x2 is 1 minus, no, this is, x2, and x1 is negative 3, so minus 3 squared plus y2 is negative 1 minus y1 is 3 squared. Okay, so of course these are the same as plus. So 1 plus 3 is 4 squared plus negative 3 minus 4, that's negative 1 minus 3, that's negative 4 squared. 4 squared is 16, negative 4 squared is 16. 16 plus 16 is 32. 32, square root of 32, use your calculator, rounds up to 5.66. So the distance between point A and this line BD is 5.66. All right, number 8. This is a you do. Please pause the video here. I'm going to wait about 3 seconds to give you a chance to pause it before I start. Try to work the problem. Once you're done watching, let's see how you did. All right, number 8. Find the distance from point E to line FH. So right here is our perpendicular line from point E to our line segment FH. So G is going to be our x2, y2. E is going to be our x1, y1. Going to use the distance formula. Again, x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. All right, so our x2 is 1 minus x1 is negative 4 squared plus y sub 2 is 2 minus y sub 1 is negative 3 squared. All right, getting close to getting off the paper there. Let's scoot over. So these two negatives mean that we change that to a positive. Same thing here. So it's 1 plus 4, which is 5. Let's not forget our square root. So 1 plus 4 is 5 squared plus 2 plus 3 is 5 squared. 5 squared is 25. 5 squared is 25. Square root of 50 is 7.07 using the calculator. So our distance between point E, line segment FH, is 7.07. Okay. Okay, by definition, parallel lines do not intersect. An alternate definition states that two lines in a plane are parallel if they are always equidistant. Two lines are equidistant from each other if the distance between the two lines measured along a perpendicular, and we lost some notes here, but this, again, the perpendicular point between the two here, these two lines would be equidistant because they're parallel. And notice so we have the arrows here at the end to indicate that they're lines, but we have an extra arrow, and these indicate that they're parallel. And these are parallel because they're equidistant. So distance between parallel lines. The distance between parallel lines is the perpendicular distance between one of the lines and any point on the other line. So perpendicular one, and of course if it's perpendicular on one end, it's perpendicular on the other, but we'll leave it like that. Theorem 3.24 says two lines equidistant from a third. In a plane, if two lines are equidistant from a third line, then the two lines are parallel to each other. So in this one here, we're talking about our third line is x. Notice V and W both have the second little arrow, so they're parallel, and it's because the distance here is D and the distance here is D, or those distances are equal or congruent. And it says over here, if line W and V are equidistant from line X, then V and W are parallel, which is essentially what I just told you. All right, bottom of page 13. We do, so this is an I do. Find the distance between the two lines. So let me show you guys another way to find the distance. We of course plot some points, or if you find a point on this line, so, and notice here, there's this crosses here. So I can go from here to here, that's 1, and then from here over here, you notice that's 1, 2. So 1, 2. And we draw using proper tools. We draw a line between those two. We have a right angle, and we can use the Pythagorean theorem to get C, or the distance between these two lines. So a squared plus b squared equals c squared. A squared is 1 squared plus the b squared here is 2 squared equals c squared. So 1 squared is 1, 2 squared is 4, 1 plus 4 is 5. So now we need to take the square root. C is going to be the square root of 5. We use our calculator. 1 second. Sorry, I had all these other ones already written out. All right, square root of 5 is approximately 2.24. So our distance between these two lines is 2.24. You guys have any questions? Let me know in class, or send me a message on Teams or in Focus. Until next time, you guys have a great night.